So here we are. We're moving on to question 3. And question 3, when we look at it here, we're saying to ourselves, when we look through it, we see the phrase normal distribution, and we're thinking to ourselves, okay, this might be a Z-score question. It says the following: North Dublin Oil Limited supply home heating oil to homes in Dublin and the surrounding hinterland. The volume in litres of oil purchased per home visit last month was recorded and analysed. The random variable x, where x is the volume of oil produced or purchased, follows a normal distribution with mean 520 litres and standard deviation of 80 litres. A customer is chosen at random. Use the empirical rule to estimate the percentage of households that purchased over 680 litres of home heating oil. Okay, so in this case, you're saying to yourself, okay, you kind of have the idea at the start. You see empirical rule, and hopefully that's giving you an idea of how to go about the question. I'd always advise in a question like this to read it a couple of times to make sure you have a clear idea of the question before you get started. So we know about the empirical rule. We know the idea that we say that 68% of all the values lie within one standard deviation of the mean. 95% of all the values lie within 2 standard deviations of the mean, above and below, and 99.7% of all values lie within 3 standard deviations, again, above and below the mean. So in our case here, we're asked to find the percentage of households that purchased over 680 litres of home heating oil. So in this case, we can see that 680 is going to turn out to be 2 standard deviations above the mean. So the mean is 520. The standard deviation is 80. 80 plus 80 is 160. So it's 2 standard deviations above the mean. So we'd say to ourselves, okay, what part or what percentage of people are above 2 standard deviations to the right of the mean? Well, we know that 50% of people are to the right of the mean. Since we know 95% of all values lie within 2 standard deviations of the mean, we can figure out that half of 95 is 47.5. So 47.5% of people lie between the mean and 2 standard deviations above the mean, and that leaves us only 2.5% in this little part here on the right, and that's equal to 10 marks.
So this one is a 0, 4, 7, 10 scale. And on this one, for low partial credit, we're looking for any relevant work, so any work of merit. So an example would be if you drew out the normal distribution and correctly wrote on the values of 68% for 1 standard deviation either side, for 95% for 2 standard deviations, and 99.7 for 3 standard deviations. So correctly identifying that normal distribution with the correct percentages for the standard deviations either side of your mean. That would be low partial credit. For high partial credit, it's correctly identifying that this question lies within 2 standard deviations, so therefore you're looking at the 95%. Okay, so correctly identifying 95% as what you are dealing with, and then you would go on to get the 5% and half it. You can either do it the way we've given here in the PowerPoint, which is you half it first and then take it away from 50, or you can do 100%, take off the 95%, and then half that. That's the way it's given in the scheme. Either of those are absolutely right. And if you identify that 95% correctly, you can get the high partial credit here for 7 marks.
Yeah, and in some ways, it's an easier way to do it, isn't it? If you just know that 95% is between 2 standard deviations, and then you've just got a 2.5% on the right-hand side of that, and a 2.5% on the little bit on the tail on the left-hand side. So that's probably it.
Yeah, absolutely. But either of them are fine. Yeah.
Okay. Perfect. Okay. So with part A done, part B, you can do part B without ever doing part A. Again, that's always a bit of learning from doing these exams. We're asked to find the probability that a customer chosen at random will order oil between 460 litres and 700 litres. So this is a Z-score question because there's no table book out there anywhere that tells us the likelihood that a customer orders between 460 and 700 liters. However, because it's normally distributed, we can change our probability value for a particular X into a Z score, and there is a table on page 36 and 37 of our table book which will tell us the relevant probability. Okay, so our Z is equal to X minus mu over sigma, where X is the value in question, mu is the mean, and sigma is the standard deviation. So in our case, we know mu is equal to 520 and sigma is equal to 80. So what are we saying? In our first case, we're going to be looking at maybe the 700, and we're going to say, okay, Z1, 700 minus 520 is equal to, divided by 80, okay? So X is 700. That's 2.25 standard deviations, okay? 2.25 standard deviations above the mean. The part in green here is the percentage of the area under the curve, which is to the left of Z1, okay? Or you can say, what is the probability any Z score taken at random will be less than 2.25 standard deviations? And the answer, when you look it up on page 37, let's look for 2.25. So here's my 2.2. I go out to 2.25, and I'm going to have 0.9878. Okay, so 0.9878. So we have that there. Okay, so that's our first part. But we must also take into account that we want to eliminate the people who ordered less than 460 liters. So we work out the equivalent Z value here. So Z2 is equal to 460 minus 520 over 80. That's minus 0.75. So Z2 here is at minus 0.75 standard deviation. So 0.75 standard deviations below the mean. We want to work out this part in white and take that away from the 98.78%. Okay, what do? We know that the probability of having a Z score less than minus 0.75 is the same as the probability of a Z score greater than plus 0.75. So somewhere around here, plus 0.75. So those two areas shaded would be the same. So the probability of a Z score less than minus 0.75 is equal to 1 minus the probability. Let me say it one more time. The probability of a Z score less than minus 0.75 is the same as the probability of having a Z score greater than plus 0.75. That's equal to 1 minus the probability of the Z score less than 0.75, and that's what I have here. So again, I go back to my table book. This time I'm going to page 36. I'm looking up 0.75, and my answer is 0.7734. Okay, so I have 1 minus 0.7734, and I get 0.2266. Okay, what happens next? I take away the 0.2266 from the 0.9878, and I get my final answer to be 0.7612 or 76.12%. I can say that's the probability of having a Z score between minus 0.75 and 2.25 standard deviations, and that is the same as having an X value between 460 liters and 700 liters. And that was a 10-mark question.
So this one is marked on a 0, 4, 7, 10 scale. So for low partial credit, we're looking for any relevant step. So trying to find a Z score. If you only find one of them, that would be fine. That would count as a relevant step. If you wrote out the equation for the Z score and had some correct substitution, that would also count as a relevant step. Okay, so anything you've done that really gets you started and has some correct working on this question would count as low partial credit for 4 marks. For high partial credit, we are looking for either finding the correct probability for Z being greater than or equal to the minus 0.75, or we're looking for the probability of less or equal to the 2.25, or both, but then you fail to finish the question. So you're looking for either correct probabilities, or if you had both of them and then do not complete the question, that is 7 marks for high partial credit.
Okay. So what are we on to? We're on to part C. A tricky little question. You want to read this part a couple of times. The cost of oil remain constant at 0.89 of a euro, so 89 cents per litre during this time period. Given that 90% of customers spend more than N euro on oil, find the value of N correct to the nearest cent. Okay, so what do we do here? Well, again, you start off and you say to yourself, okay, we know that 90% of the customers spent more than N euro on oil. So let me just click here for 1 second. What we're saying here is that 90% of people are going to have spent more than N euro on oil. So to the right of a certain Z value is going to lie 90% of all the values. Okay. To the left of that will be 10% of the values. We know, of course, that we can't deal with the left-hand side of the bell curve because page 36 and 37 don't deal with that. Instead, they deal with the right-hand side. But we know the curve is symmetrical, so I can say that this part over here, if Z1 and Z2 are of the same absolute value, I can say that this part here is also 10% of 10% of the area underneath the curve. So here's what I can say. The probability of having any Z value less than or equal to Z1 is 0.9, 90%. Okay. When I look that up in the table book, I go to page 37. Okay. I know some students would sometimes find it a bit tricky, this logic. Let me just click back here for 1 second, see what I'm looking for. 0.9, right? So when I go here to page 37, I'm looking for 0.9 here in my table. So I'm looking around here and I'm saying, okay, where's my closest value to 0.9? I looked at 1.2, and as I work my way across this line, I get over to 0.8997, and that's a Z score of 1.2 standard deviations. And that's as close as I can get because that's closer to the next value of 0.915. So my Z score here, my Z1 is 1.28 standard deviations. Therefore, the Z2 over on this side is going to be minus 1.28 standard deviations. That's going to be the relevant value for us, the minus 1.28. Okay, once we have that, we can say, right, now we actually must change this back to answer the actual question. So what do? We say Z is equal to X minus mu over sigma. Now we know Z. We know that Z is equal to minus 1.28. Of course, we know mu is 520 and we know that sigma is 80. We multiply across by the 80. So multiply across by the 80, and then we bring over the minus 520 by adding 520 to both sides, and we get our value here. We get our value here, which is 417.6 liters. And what do we get? Well, we're saying to ourselves, this is the part now where if you got this far, you got to just keep on going till the end here. They've ordered 417.6 liters. The price per liter is 0.89. You multiply it through and you get 371.664. And because, of course, we're dealing with cents, it's 371.66. And that's a 5-mark question.
So this one's marked on a 0, 3, 4, 5 scale. So low partial credit here is finding the Z score of 1.28. So if you did the work there, you looked up your Z score and you wrote down Z equals 1.28, that would get you low partial credit. The high partial credit here for 4 marks is finding the correct number of litres, so the 417.6, but then fails to work out the amount of money. So fails to multiply that by the 0.89 cents. So that would be 4 marks here. And this, because it's asked to the nearest cent, it is a starred question. So for rounding, you drop 1 mark if your rounding is incorrect. So it would drop to 4 marks for incorrect rounding.
Okay.
And
okay.
sorry, Owen, I'll just say one thing
there
about that. This is actually the second question that has happened in the paper where when you have a starred question, it's the same number of marks as high partial credit. And someone who's taking this exam might think, I'm getting the same marks here for a rounding error as someone who didn't multiply through by the 0.89. But that does actually happen in the leaving. And that does happen, depends on the scale of the question, because often high partial credit on a 5 mark question would be 4 marks. So especially on 5 mark questions, that does happen.
Okay. So I think another thing that does happen, and correct me if I'm wrong here, Andrea, is like that we're seeing here, this is a 5 mark question. And like it was a tough work for that 5 marks. But at the tail end of a question like this, excuse the bell curve pun there, but at this part of a question, sometimes that's the case, and that the hard one here is only worth the 5 marks at the end.
Yeah, absolutely. Unfortunately, it's not as straightforward as the hard questions are worth more marks and the easy questions worth less marks, which is probably a good thing in places as well.
Yeah, exactly,
It
exactly.
you may well get a question like this that would be worth the 5 marks, and you might be getting 10 marks or something that was a lot simpler. It's different for every question.
Yeah. Okay. Okay. Andrea, let's get ready to move on. So, and we'll move on to question 4.